Hello, this is part 2 of our expected value notes video. These are just a little more maybe complicated examples, so I wanted to isolate those. You might also notice that on my guided notes here I have the same questions twice, so we only have 3 new examples to take a look at. Alright, so we know that to calculate expected value, we need to do the sum of the x's times the p of x from a probability distribution. Okay, so the first thing we have to do is be able to set up our probability distribution. All right, for first example, for a daily lottery, a person selects a 3-digit number. If the person plays for $1, she can win 300. Find the expected value for the ticket. Okay, so as we've seen previously, we have an x and a p of x. Okay, so if you win the $300 prize, what really is your gain? Okay, and you got to remember what it costs for you to play. In this example, it costs you $1. That looks to me like it should be a dollar sign. So you're right, the gain should be $299. Okay, if they don't pick you, then you're going to show a loss of $1. Okay, so I think we've got that under control. Now, the different part on this is that it's a daily lottery and you're picking a 3-digit number. So the question becomes, how many tickets are there? Okay, so how many tickets are there before we can figure out what these probabilities are over here for the p of x's? Okay, well, how many single digits are there to pick from? Okay, well, I want to put those up here. Wouldn't you have 0 through 9 for single digits? So that means there would be 10 numbers available. Okay, so if I'm picking 3, I have 10 digits to pick from, then I would have 10 more, and then I would have 10 more. So if you multiply those together, you'll find that you have 1,000 tickets having three digits. Okay, so how many are going to win? Well, 1 out of 1,000. And the rest, 999 out of 1,000, are the losers. So then we have the expected value is going to be 299 times 1 over 1,000 plus -1 times 999 over 1,000. And if you do the math on that, I'm running out of space here, you're going to lose on average 70 cents out of every dollar. Okay, so that was the expected value. But truly, the new part is this, how to figure out how many tickets there were. So we had a 3-digit, so there were 10 choices for each. Okay, so if you think about it, if it were a 4-digit, you just have another times 10 on here. So there would be, 10,000 tickets and so forth. Okay, going to play again. In the same lottery, if a person boxes a number, okay, so this is different yet again, boxes a number, she will win $70. Find the expected value if the number 824 is played for $1 and boxed. Okay, so first thing, I had to have an understanding of what does it mean to have a boxed lottery. Okay, well, boxed means you win if the numbers appear in any order. Okay, so if the numbers appear in any order. So in other words, 824 wins, 284 wins, 248 wins, and so forth. Okay, so then the question is, well, how many winners are there? Or how many ways are there to organize 3 digits? Well, you would have 3 digits to pick from in the first slot. Okay, then if you pick one, there'd be 2 left over. If you pick one, then there'd be 1. So there'd be 6 ways to win. Okay, then the other part is, well, how many tickets are there? Well, it's still 3 digits. So it's still 10 times 10 times 10 for the number of tickets there are. All right, so when you do your probability distribution, kind of running us out of room here, okay, so we gain, okay, the winning is $70, so you gain 69 or you lose your dollar. I'm sorry, kind of cramming this in here. There's 6 winners out of 1,000 tickets, because there's 6 ways to win with the box. The rest are losers, 994 over 1,000. Okay, so then your expected value, you've got 69 times 6 over 1,000 plus -1 times 994 over 1,000. Okay, and I found on this one we're still losing money. This time, on average, 58 cents on every dollar you play. All right, one more. A $2,000 life insurance policy is purchased for $400. The chance of Turney Mint living another year is 0.98. Find the expected value of the policy. Okay, and anytime we do life insurance, we are the company. Okay, just take it from that perspective. We're the company. Okay, so we're going to set up our probability distribution. Okay, and we got to think about, what does it mean to have life insurance? And I'm sure a lot of you guys have never even had any encounters with this, so we'll try and explain this to you. Okay, so we're an insurance company. Okay, you and I, insurance company. We're going to go knock on a door, knock, 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 and say, hey, I'm going to pay you, or have a life insurance policy for you, 2,000 women. Try that again. Knock on the door, knock, knock, knock. I'm going to say, I'm going to sell you a $2,000 life insurance policy for $400. Okay? So the way it works is, if you live, all you lose is your $400. Okay? If you don't live, your family is going to gain $2,000. Okay? So that's what happens to you as a consumer. All right. So for us as the company, if we sell this policy, we are going to have income of $400, because Joe consumer is going to write us a check and say, hey, here you go. Here's $400. I want you to insure me. Okay. So if this person that you sold this to lives another year, okay, all that happens is we keep his money or her money. $400, he lives, 0.98, done deal. Okay. However, if the person doesn't make it, we as the company have to pay out some money. We're going to lose money. How much are we going to lose? That's the question. Okay, well, your gut is to say $2,000, because it's a $2,000 life insurance policy. And I agree with you. We will pay out $2,000. But what did we bring in against that? What was our income? Okay, if you're thinking $400, you're right. So our net loss is $1,600. And kind of, if you look here between the 400 and the 16, you kind of see the 2,000 sitting there. Now, what's the chance we lose that money? Well, if this is 0.98, remember the P of X's have to add up to be 1, so that would be 0.02. Okay, so then we have an expected value of 400 times 0.98 plus negative 1,600 times 0.02. Okay, and we should get, or I got $360 to the positive. Okay, so for every policy that we sell of this type, our company is making $360. So the question is, should I keep selling it or not? Okay, since this is positive, I absolutely will keep selling it. If it had come out a negative expected value for the policy, I would quit selling it, because I'm going to bankrupt my company. Okay, so I think maybe that will help you out with this different type, or these lottery type of questions. I might just add something here at the bottom, just real quick. When you calculate the number of tickets, okay, and if I said 3-digit, I think we saw up there at the top, it was 10 times 10 times 10. If it's 4-digit, it was 10, 10, 10, 10. If it's a 5-digit, 1, 2, 3, 4, 5, you'd have 10 to the 5th if you want. Okay, so it's like 10 to the 4th, 10 to the 5th, and so forth. If you're calculating boxed lottery, you have number of winners. Okay, so if it's a 3-digit, we said it would be a 3 times 2 times 1, because that's how many numbers that you have. So you have this many ways to arrange them to win. So you'd have 6 winners. Okay, or you could even say 3 factorial. We've not talked about factorial, but you might know that anyway. If it's a 4-digit box, 1, 2, 3, 4, it'd be like doing 4 times 3 times 2 times 1, or you tell me there's 24 ways to win. 5-digit box, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, multiplied together, okay, which is, what, 120 winners? So it goes 4 factorial, 5 factorial, and so forth when you're dealing with the box lottery. So this is number of tickets. This is the number of winners on a box. Hope you found this helpful, and if not, I'm sure I'll be talking to you soon. Thank you for watching. Have a good evening.